Hey guys, this lesson is all about proving that lines are parallel based on information about corresponding angles, alternate interior angles, same side interior angles, or alternate exterior angles. Well, sometimes we will prove that the lines are parallel, and sometimes we will prove that they are not parallel. Alright, in the day 2 video, we learned what corresponding angles are, what alternate interior angles are, and what alternate exterior angles are. And we learned that if you have two parallel lines that are being cut by a transversal, then corresponding angles are congruent. And alternate interior angles are congruent. And alternate exterior angles such as these are also congruent. We learned about one additional angle pair. These are called consecutive interior angles, or sometimes they are called same side interior angles. And obviously they are not congruent. You can see that one is acute and one is obtuse, and instead we found that they were supplementary. Okay, meaning that they add up to 180 degrees. Alright, so memorize those facts. And but what we're going to talk about today is that the converse is also true. If we know that a pair of angles that would be corresponding angles, if we know that they are congruent, then that proves that the lines are parallel lines. If we are given that alternate interior angles are congruent, then the lines have to be parallel. And if we find that alternate exterior angles are congruent, that proves that the lines are parallel. And you will see me abbreviate these postulates in this way. I will say something like, so these are corresponding angles. So I would say corresponding angles congruent implies parallel lines. Alright, something like that. Or maybe I'll put the congruent first. By the way, this is the symbol for congruent. Alright, an equal sign with a tilde over it. It means almost the same thing as equal, but equal is for numbers, congruent is for figures, like pictures. So anyway, I might say congruent corresponding angles. Alright, and that's how I would abbreviate that. Imply parallel lines. So look at problem number 1. Given that A and B are parallel, we can conclude that angle 2 is congruent to angle 7. Why? Well, angle 2 and angle 7 are alternate interior angles. So the postulate that would support this conclusion, I'm going to abbreviate it, but parallel lines imply congruent alternate interior angles. Alright, that would be a good way to abbreviate that postulate. Alright, in other words, if you have parallel lines, then alternate interior angles are congruent. Okay, now look at number 2. Given that angle 4 plus, the measure of angle 4 plus the measure of angle 7 equal 180, conclusion A is parallel to B. Why? Well, let's see, what are these? So we have angle 4 and angle 7. What type of angles are these? Well, these are consecutive angles, consecutive interior angles. And we have learned that consecutive interior angles are only supplementary when the lines are parallel. So we can say, so consecutive interior angles supplementary implies that the lines are parallel. You could abbreviate some of these words, but I want to make it extra clear. Look at number 3. Given angle 4 is congruent to angle 5. Conclusion, A is parallel to B. Why? Well, let's see. What are angles 4 and 5? Well, angles 4 and 5 are alternate interior angles. Alright, so the fact that they are congruent implies that the lines are parallel. And you could abbreviate that this way. Alternate interior angles congruent implies lines parallel. In other words, if alternate interior angles are congruent, then lines are parallel. Alright, how about number 4? Find the values of x and y. Explain your reasoning by stating the proper theorem or postulate. Okay, well, you see the 130 and the x are corresponding angles. And do you see these arrows here that are on the lines? These arrows mean that the lines are parallel. So if the lines are parallel, the corresponding angles should be equal. That means x is 130. And here we should go ahead and abbreviate the postulate. So lines parallel implies corresponding angles are congruent. That's the theorem that we need to justify that. And what about angle y? Well, if angle x is 130, then angle y is also 130. This has nothing to do with parallel lines. Vertical angles are always congruent. So y is also 130 because vertical angles are congruent. Alright, these little marks are a little off, but these are also supposed to be parallel lines. So, if in case we need it, it's there. If this is 65 degrees, we can figure out, well, let's go ahead and jump to angle x. Because angle x and the 65 are corresponding angles. So that's going to be the same exact thing as number 4. So if this is 65, then x will be 65, and it's going to be the exact same postulate or theorem. Lines parallel imply corresponding angles congruent. In fact, I'm just going to cut and paste that down here. Now, how about angle y? How will I find that? Well, angle y and the 65 form a linear pair. Alright, because you can see that together they form a straight line. And we know that a linear pair is always supplementary, so we can just do 180 minus 65. So that is 115. Alright, so we know that y is 115, and we can just say that linear pairs are supplementary. Okay, linear pairs are supplementary. Alright, and we might figure out some nice ways to abbreviate that, but I need to talk to other teachers and figure out, sort of agree on proper ways to abbreviate. So for now I'm going to write a lot of things out the long way. Anyway, let's look at this. For x and y and such, it's looking like a lot of the same type of thing. The x and the 80 are a linear pair. Alright, you see the straight line that they form right here. So these two have to add up to 180. So if this is 80, that means this must be 100. So x must be 100 for the same reason as the last problem. Linear pairs are supplementary. Alright, now meanwhile, angle y and this 80 are alternate exterior angles. And alternate exterior angles are congruent when the lines are parallel. And we are given the parallel lines here once again. Alright, so in other words, parallel lines imply alternate exterior angles are congruent. Alright, there you go. Parallel lines imply alternate exterior angles are congruent. In other words, if the lines are parallel, then alternate exterior angles are congruent. That's another way to read this. So that was number 6. How about number 7? Find the value of x so that n is parallel to m. Then once again we got to state the theorem or postulate that justifies. Well, these are once again alternate exterior angles. So these lines are only going to be parallel if the alternate exterior angles are congruent. Okay, so that means we have ourselves a little equation that we need to solve to find the appropriate x. So I guess we'll do that over here. 5x should equal 3x plus 48. Subtracting 3x from both sides gives us 2x equals 48. Dividing by 2 tells us that x is going to equal 24. So I'll go ahead and jump straight to here and say x equals 24. And then we're trying to make sure that these lines are parallel. So we will say alternate exterior angles congruent implies lines parallel. Okay, something just like this. Alright, how about number 8? Well, the key to focus on is the fact that these angles right here are corresponding angles. Okay, so we'll go ahead and solve this, and then we'll say corresponding angles congruent implies lines parallel. First we have to solve the equation. 7x plus 13 equals 5x plus 23. In case you're wondering why I put this on the left and that on the right, I'm putting the bigger x on the left. It just makes it easier to come out positive. So this way, when I subtract 5x from both sides, I will have a positive number. So I'll have 2x plus 13 is equal to 23. And then when I subtract 13 from both sides, okay, so that's 10. So I'm getting x is equal to 10. Better put a box around it. And now I'm going to say that theorem, corresponding angles congruent implies lines parallel. Okay, just like that. Alright, number 9. Now these are consecutive interior angles, and for these lines to be parallel, they need to be supplementary. So once again I'm going to solve an equation, but this time I'm not going to just set these equal to each other. I'm going to make sure that they add up to 180. So I'm going to do something like this. 5x minus 18, alright, plus 8x minus 5 should equal 180. Now 8 plus 5 is 13, so this makes 13x. Negative 18 and negative 5, that's going to make, let's see, negative 23, I believe. Okay, is equal to 180. Now we'll add 23 to both sides. So that's going to give me 13x is equal to, looks like 203. Now I'm going to divide both sides by 13. Alright, and I'm getting 15.6. I'm wondering if I made a mistake. Just going to double check my work real quick. Alright, I don't see anything wrong with my work, so I'm going to stick with this answer. So x is 15.6 approximately. Anyway, so the postulate is, like I said before, consecutive interior angle supplementary implies lines parallel. Okay, and there you go. So that was number 9. Okay, how about number 10? Alright, for these last 3, we're not doing any actual calculations, just can you prove that P and Q are parallel? If so, state the theorem or postulate that you would use. How about this? These markings mean that these two angles are congruent. So these two angles are what type of angle pair? Well, these are corresponding angles. And we do have a theorem that says corresponding angles congruent implies lines parallel. In other words, if corresponding angles are congruent, then the lines are parallel. So, yes, we can prove it. So I guess we could just say a big yes up here, and then down here we could write the postulate. Corresponding angles congruent implies lines parallel. In other words, if, or this could be read, if corresponding angles are congruent, then lines are parallel. Okay, what about this one? Well, these are alternate interior angles, and these markings mean that they are supposed to be congruent. So that is enough to prove that P and Q are parallel, because if alternate interior angles are congruent, then the lines are parallel. That's our postulate. And again, you can read this in 2 ways. You could either say alternate interior angles congruent implies lines parallel, or you could say if alternate interior angles are congruent, then the lines are parallel. Alright? Either way, it's an acceptable way of saying the theorem or postulate. Okay, number 12. Last one for this video. Well, these angles are marked congruent, which makes sense because they are vertical angles. So the question is that enough to prove that these lines are parallel? And the answer is no. Vertical angles are always equal, regardless of whether the lines are parallel. So obviously that means there won't be any theorem to use, because we can't prove that they are parallel just because vertical angles are congruent. And alright, that's enough for this video, and I hope it was helpful to you. This homework assignment, if you're actually a student in my class at Roswell High School, the homework has there's this entire back to it, which has another like 30 problems. Like another 15 problems on it, which are all sort of the same. You're either setting the expressions equal to each other, or you're adding them up and setting them equal to 180. So we've already done several problems like that, looking at problems number 7, 8, and 9. So those should give you the idea of how to do the rest. So if you have been assigned all these problems, I'm not going to make a video for them, because this video already is covering that, and you should be able to do the rest on your own. So hope this has been helpful. I will see you guys on the next video, which will not be today.